Hello? Yes, hello. Do you have a problem, kid? Well, yes, I do have a problem. It says the film is 3D, but time is not a dimension.
Time is not a dimension.
Yes, it is. So, are we just gonna watch nothing? Kid, you've lost me. Stop being so sciencey. Stop being science. Are you gonna get this movie? Okay? You gonna watch it or just give me your money or not? Go away then. Okay.
What I said is sorry. Time is in fact a fourth dimension.
Now that we understand that time is a dimension, we can think of gravity as being caused by a great mass put on a fabric, and this fabric is in space, called space-time.
Because space is being affected by the mass put on space-time, the time in space-time is also being affected by the mass.
This means that when I'm on this apartment, I'm further away from the core, which is pulling everything as close to it, and that's what the gravity is doing to us right now. Gravity is affecting me slightly less than if I was on the ground. Down here, I'm more affected by the gravity of the Earth's core. This means that I am more affected by gravity on the ground than in the apartment.
Another example of this is if I go near a black hole, well, I would die.
Other than that, if I was on the event horizon and miraculously wasn't sucked in by the black hole's immense gravity, I would actually be aging slower than everyone on Earth, since the black hole has a greater gravity than Earth, meaning I would be traveling into Earth's future.
Einstein also set out a law of general relativity. I will show this to you by making this house into a spaceship. In this law, Einstein stated that another way of traveling to the future was by literally moving in a direction. The faster you moved and longer you traveled in a direction, the more time slowed down for you. This happens because when you move at a constant rate, we feel as if we are still.
But when an observer from outside of the ship sees you moving, they clearly see you moving in a direction, and due to this, anything bouncing up and down for you will appear just bouncing up and down, whereas for them, it's going to appear in a zigzag form. If I started bouncing the ball before or after I started moving, to me the distances would have been the same, because I was inside of the moving spaceship. But for the person outside of the spaceship, they can clearly see the distance of the ball has increased, but their seconds stay the same. Peggy Whitson spent a whole 665 days orbiting Earth, but because of this, she ended up traveling a whole 0.02 seconds into the future.
Who knows when we'll even travel close to the speed of light to be able to have a time travel to the future that's even visible. Or who knows when we'll even be able to go to the event horizon or even reach a black hole without dying. Well, whoever figures that out, well, they would be a genius. Thank you for watching. I'm Jamie.